This is your LEAP review video, part 1. Almost all these questions are going to come straight from the LEAP practice test for Louisiana. The first one, we're going to go through different standards that we've talked about before Christmas, that it's been a while since we've touched on, just to kind of keep them fresh in our memory. The first one says, which of these expressions represent solution to the equation y to the third equals 64? Now I know that's hard to see, so I'm going to rewrite it. It's y to the third equals 64. It says select each correct answer, and we know when it says select each correct answer that we're going to select more than one. So the first thing that we have to do here is figure out how to solve y to the third equals 64. What is the opposite of going to the third power? And the opposite of going to the third power is to cube root it. Remember, we have square roots and we have cube roots. If this was y to the second power, we would square root it. But it's y to the third power, so we're going to cube root it, which means we're looking for a number that can be multiplied by itself 3 times to get us 64. So something like 2 times 2 times 2. What's the answer there? 3 times 3 times 3. 4 times 4 times 4, and so on. The answer here is going to be 4 times 4 times 4. Well, 4 times 4 is 16, and 16 times another 4 is 64. That is why your answer is 4. So if I'm looking at my answer choices, I know one of the answer choices that is correct is 4. Now I'm looking at the other ones because I have to have another answer choice that is correct, at least one. Negative 4. Some people think the answer can be negative 4. Well, let's try it out. Negative 4 times negative 4 gives me a positive 16. And when I multiply that positive 16 times another negative 4, I actually get a negative 64. So my answer that I'm looking for is not negative 64. I'm looking for a positive 64. So that's out. 8 and negative 8, that's not possible. That's going to be a very, very huge number if we multiply those 3 times. They basically put those there to confuse you in case you didn't notice the 3. If you do the square root of 64, the square root of 64 is 8. So they're kind of trying to trick you there. And then you have A and B, and we know A and B has to be, one of them has to be correct. The only difference in A and B is this A has a negative and B does not. Well, do we have a negative here when we cube root our 64? No. So the other correct answer is B, and that's the only correct answer we have, the B and F. So the way I want to work this series of problems is I want you to pause the video and see if you can work this one on your own. We're going to do this several times. Pause it and see if you can work this on your own. And when you get finished, you can restart it and you can watch me solve it. So now press pause. All right. Let's see if you got this one correct. It's very similar to the first one. You're going to also have to take the cube root. And again, you're thinking what times what is going to give me 27. Well, what is 2 times 2 times 2? 2 times 2 is 4, and 4 times another 2 is 8. 8 is not what we're looking for. We're looking for 27. So let's try 3. 3 times 3 is 9, and 9 times another 3 is 27, which is what we are looking for there. So you should have put in this box or on this line 3. Sometimes on the LEAP test they'll say enter your answer in the box. Sometimes there'll be multiple choice like the first one. So we try to do a mixture of everything. But the key for these problems is to know that when you see something to the third, you have to take the cube root in order to get rid of it, and you're just left with x equals 3 because the cube root and 3 cancel each other out. Same thing if you were to have a question that had a square, instead of taking the cube root, you would do the square root. question. I did not mention before, but almost all of these questions are going to be on the no calculator section, which is the very first section of the LEAP test. So the previous questions and these questions following are going to be on the no calculator section. Whenever we get to a question that will be on the calculator section, I'll be sure to point that out, but this is not on the calculator section. So it says which decimal is equivalent to 6/11. I think this is the very first standard we learned in August. The key here where people make a mistake is they don't remember how to set it up, because you have to do long division. Well, I use the phrase the top number falls into the house, and I call this the house. So that top number is going to end up in this house. And I just put as many zeros as I think I need. I'm looking at my answer choice and I see 3 things here. I'm going to go ahead and put one more 0. If I need it, great. If not, that's fine. The key here when you're doing long division is to keep everything lined up. So I'm going to go ahead and put my decimal, move it up, and just listen to what I say and how I say it, because the process of long division is not hard, but it is easy to forget because we don't use it that often. Can 11 go into 6? No, it's too big. Can 11 go into 60? Yes, it can. How many times can 11 go into 60? It can go into 65 times, because 5 times 11 is 55. And remember, keep everything lined up. Oops, not add. What are we supposed to do there? We're supposed to subtract. So 60 minus 55 is 5. Bring down my 0. Add 11 into 50. Can 11 go into 50? Yes. How many times can 11 go into 50? 4 times. 4 times 11 is 44. Again, I'm going to subtract. 50 minus 44 is 6. Bring down another 0. And I can see at this point that these two are not going to be correct answers, but I've got to see what is going to repeat, because the difference in C and D is this shows the 4 repeating and this shows the 5 and the 4 repeating. So bring down my 0. Can 11 go into 60? Yes, it can go into it 5 times. When you multiply 5 times 11, you get 55 again. Subtract, and you get 60 minus 55 is 5. Bring down that other 0, and you can kind of see what the pattern is going to be at this point. 11 can go into 50 4 times, and we can go on with this literally forever, and we keep getting 54, 54, 54. So the answer here is going to be D, because it's not just the 4 that's repeating, it is the 5 and the 4 that's repeating. Make sure you set this up correctly. Make sure that you don't put the 6 on the outside, that you put the 11 on the outside. That is one of the biggest mistakes with these problems. Press pause and try to solve this on your own. That is 5/6. If we are doing 5/6, what number is going to go in the house? That top number, right? So I'm going to go ahead and set this up. 6 on the outside, 5 on the inside. I don't know how many zeros I need, so I'm just going to put 3 to start with, and if I need to put more, I can. If I don't need that many, I can not use that many. It doesn't matter. Again, I'm going to go ahead and bring my decimal up and start the process. Can 6 go into 5? No. Can 6 go into 50? Yes, and just think about your 6 times tables. 6 can go into 50 8 times, because 8 times 6 is 48. And we subtract. 50 minus 48 is 2. Bring down a 0. 6 can go into 20 3 times. 3 times 6 is 18. I subtract and I get 2. 6 can go into 20 again 3 times. 3 times 6 is 18. I subtract and I get 2, and I don't have any zeros, so if I were to keep bringing down zeros over and over and over and over, what number is going to repeat. Is it 8, 3, or is it just a 3? And we can see that the 8 does not repeat. We're going to keep getting 3 over and over, and this process is going to keep going over and over and over and over. So again, just like I said with the previous problem, sometimes they give you a box to put your answer in, and sometimes they don't. Sometimes it's multiple choice. So if you had to put your answer in the box here, you would write 0.83, repeating, but most likely this would be a multiple choice question. All right, next question. Which of these input-output tables represent a function? Select each correct answer, and I underlined that already for you, but it's not going to be underlined on your LEAP test. So make sure you pay attention to those questions. Make sure we're going to, at the end of this problem, we have to have more than one answer. That is correct. Input and output. We talked about this at the very beginning of the year, and there's a rule that makes something represent a function. And that rule is, and we wrote this statement many, many times, every input has only one output. Every input has only one output. And input numbers are also recognized as your x values and your y values. So you can restate that statement and just say every x value has only one y value. But in this case, you can see their input-output values. So we're looking at our inputs. In order for it to be a function, every input has only one output. If it has more than one output, it's not a function. So A is not correct because one has an output of 4, one has an output of 6. Okay, kind of like I believe I've given examples of a Coke machine. If I put money in the Coke machine and I press the root beer button, I should get a root beer out. Only one root beer out, but I should get a root beer out. I should not get a Sprite or Dr. Pepper. You should get one output, and it should be the correct output. So that's not correct there. B is not correct because you have an output of 6 and 1. C, look at your input values. They're all different. C is correct. D, look at your input values. They're all different. D is correct. E, correct or incorrect? What do you think? It's incorrect because one has an output of 4 and one has an output of 5. So the only correct answers here are C and D. Now notice that I didn't really look at these output values because they don't matter. They truly don't. Your outputs can all be the same. You could have 4, 4, 4, 4 here, and it would still be a correct answer. So make sure you understand that. I want you to try this next question on your own. So go ahead and press pause and try that one on your own. One difference for this problem is that it says does not represent a function. Hopefully when you did that on your own, you realize that's what it was talking about. Does not represent a function. And it doesn't say select each correct answer, so we're going to just select one. There is one mapping diagram that does not represent a function. And the answer here is B. B does not represent a function because A has an output here and an output here. Now I understand those are a little bit different. We don't usually use Roman numerals or letters, but the concept is still the same. The concept is that A fails to have only one output. A has an output of Roman numeral 1 and A has an output of Roman numeral 2. All of these other ones have one line coming from here, one here, and one here. It doesn't matter if they cross, none of that matters. What matters is every input has one output. And another thing I did not mention is, how do you know that these are the input values? How do you know that these are the output values on this side? Because it's x values and y values. And when we do coordinates, it's x comma y. So your x values are always on this side, and your y values are always on this side. Vice versa, your input and your output. All right, moving on. Number 7. Polygon KLMN is the image of polygon PQRS after 180 rotation. Which angle of the polygon KLMN is congruent to angle S? Now this comes straight from the LEAP practice test, and it actually was a multiple choice question, but I took off the choices. A lot of people look at this problem, they get their tracing paper out and they say, okay, let me try this out. And then they get confused because this whole bottom part of the graph is actually missing. And when you do a 180 rotation, it actually starts in this quadrant down here. You don't have to do any of that. This is actually a very quick, easy problem if you understand what it's actually asking you. So I'm going to write these letters down. KLMN is the image of polygon PQRS after a 180 degrees rotation. Which angle of polygon KLMN is congruent to angle S? And all you have to do is look at the letters. They're in that order for a reason. The letter that matches up is N. So you would write, if this was constructor response, you would write angle N is congruent to angle S. And you don't actually have to do any rotation at all. You don't have to use your tracing paper. All you have to do is recognize that the letters are going to match. They're in that particular order for a reason. K matches with P, L matches with Q, M matches with R, and so on. They could ask you about a line. They could say, well, what line segment would match with RS? Well, RS would be MN. They can ask you lots of different questions on this topic. Make sure you know why the answer is what it is. All right, this is a two-part question coming up. I want you to press pause and try that one on your own. All right. It says, first of all, what type of transformation was used to transform figure 1 to figure 2? So we have figure 1 to figure 2. Pretty simple question as long as you know your main topics of transformations. We have reflections, rotations, translations, and dilations, and there is only one of those that changes the size of an object. Which one would change the size of object 1 to object 2, make it smaller? And the answer there is a dilation. They're not asking you for specifics there. They just want to know what type of transformation was used to transform figure 1 to figure 2. Part B. Which statement describes the transformation of figure 2 to figure 3? And you have your 4 options there. Well, I know it's not going to be a translation, because if it was a translation, it would just slide over, and it would be in the same orientation. It would just slide over here. Well, it's not sliding over, it's actually flipping. So I know it's either going to be a reflection over the x-axis and y-axis. And notice, normally they label the axis for you, and here they did not. So you are expected to know that this is the y-axis and this is the x-axis. So what axis did it flip over? From left to right, it flipped over the y-axis. So B is the correct answer there. Moving on to number 9. These questions are still considered the no calculator section. These are no calculator. We have not gotten to a single calculator question yet. So, I'll cover that bottom problem up. It says plot a point on the number line which best approximates, or in other words, estimates the location of square root 14. Again, this is something in our very first unit that we talked about. Square root of 14. I'm going to show you how to work this problem completely and fully and explain it, and then I want you to be able to work the next problem on your own. So what we do when we have a square root that we are trying to estimate. First of all, they're going to want, I've seen this on LEAP Test before, and they just give you a point and they want you to plot it. They're going to want the point on one of these hash marks, not in the middle of a hash mark, but on one of these hash marks. So if we're at 2, this hash mark would be 2.25, this is 2.5, 2.75, 3. So we have to figure out to the nearest basically 0.25, 0.5, or 0.75. What is the answer? So we have to think about our perfect square roots. We have a list of perfect square roots that you can come up with on your own. Square root 4, square root 9, square root 16, square root 25, and you can just keep on going with this. Square root 36, square root 49. Why are these perfect square roots? They're perfect square roots because the square root of 4 is 2. Square root of 9 is 3, and so on. Why are these the answers in case you don't remember square roots? Well, 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. That's not something that's given to you. That's something that you're expected to know and be able to list if you have to. So what we ask ourselves is, we have the square root of 14, which is an irrational number, meaning the decimal goes on forever. So we can only estimate it the best we can. We need to know what is the best estimate. So you create a high perfect square root and a low perfect square root. What is a square root that is higher than 14 that is perfect? And you should choose 16. What is a square root that's lower than 14 that's perfect? And you should choose 9. And what is the square root of 16? 4. Square root of 9 is 3. So I know my answer is going to be somewhere in between 3 and 4. That's what we can zone in on now. How do you get a better estimate? Well, there's a couple different ways. I like to do it this way. I say, well, how far is 14 from 16? 14, 15, 16. It is 2 away, which is not far. It's pretty close. How far away is 9 and 14? It's going to be 5 away. Okay, so I know it's going to be closer to 16 than it is 9. What's in the middle of 3 and 4? Right here in the middle. This little spot right here. 3, 4, what's in the middle is 3.5. So truthfully, I know 14 doesn't really lay in the middle. Okay, how would you know if it's in the middle and you should choose 3.5? Well, if it's something like 3 away and 4 away, or 5 away and 4 away. If it's very, very close to the middle, then you would choose the 3.5. But I know it's closer to 16, so I know my answer is actually going to be about 3.75. It's in between here somewhere. Now, if you aren't a visual person and you don't understand that, there is a second option, and that second option is to just multiply it out. Remember, this is the no calculator section, so it's going to take the time, but you can multiply decimals. So if I want to make sure that my answer is 3.75, well, what do we do here? 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. So if I think my answer is 3.75, then I just do 3.75 times 3.75, and I see what my answer is going to be. My answer should be 14 or close to 14. And if it's not, then I didn't get it right. So let's take some time to multiply this out. Like I said, it's going to take a little bit of time. 5 times 5 is 25, carry my 2. 5 times 7 is 35, 36, 37, carry my 3. 5 times 3 is 15, 16, 17, 18. Put my 0 here to move on to the next number. 7 times 5 is 35, carry my 3. 7 times 7 is 49, 50, 51, 52. When I add that 3, carry my 5. 7 times 3 is 21, plus 5 is 26. Gotta keep everything in line here. Now don't just add a 0, I add 2 zeros now because I'm moving on to my last number. 3 times 5 is 15, carry my 1. 3 times 7 is 21, plus 1 is 22, carry my 2. 3 times 3 is 9, 10, and 11. And you just add all of that together. That's going to be 5, that's 12, it's going to be 9, 10, 11, 11 plus 5 is 16, carry my 1, 6, 7, 8, 9, 10, 2, 3, 4, and I have 4 decimal places here, so I need to move over 1, 2, 3, 4. So my answer when I multiply 3.75 times 3.75 is 14.0625. You're not going to get it perfect. That's why it's an irrational number, but that is pretty close. So I know for a fact that is the correct answer. Now, using that and this process, I want you to try this next one on your own. So press pause and answer that one on your own. All right. Square root 30. Think to yourself, what is a higher and a lower perfect square root? And you can go back to the list here that we just made. Okay. Higher perfect square root is going to be 36, which is 6. A lower perfect square root is 25, which is 5. So how far away is it from 30 to 36? That is 6 away. How far away is it from 25 to 30? It is 5 away. So, what is in the middle of 6 and 5? You're going to get 5.5. And because you're 6 away and 5 away, it's not much closer to 6 than it is 5. So your answer here is going to be 5.5. Because it's about in the middle. And again, you can check it by multiplying 5.5 times 5.5. And when you do that, you're going to get, let's see what we get when we multiply this together. And you're going to add. And you get 30.25 when you add it together, which we're trying to get to 30. So again, the answer here, you put your coordinate 5.5, and that will be the correct answer. This is the end of part 1. The next video will start part 2.